So we are back from the break, and let me introduce the next speaker. Tatiana Shavrina is the leader of AGI NLP team at Sberbank. She is also giving lectures at National Research University Higher School of Economics. Tatiana has presented her main works in the field of corpus construction and linguistic interpretation of the deep learning models. She's also a shared task enthusiast and has organized 5 evaluation tracks in Russian NLP, including AI Journey 2019 on solving the final state exams with deep neural networks. Your best lecture title is Russian SuperGLUE that will be devoted to texts as an unlimited but indirect trace of human thinking process. That is the richest source for AI modeling that we have. We will learn how to handle it and where does SuperGLUE come about from Tatiana talk. She then will join our panelists panel discussion Intelligence Measures, AGI Benchmarks and Evaluations, which will be moderated by Dr. Sergey Shalyapin. So you can ask your questions to Tatiana there.
So hello everyone. Thank you so much for introducing me. Do you see my presentation now? So I would like to present Russian SuperGLUE project that our team has created at Sberbank, but also today I will touch upon several problems which we have in NLP and both in AGI, I suppose so. So we are developing a general language understanding evaluation benchmark for Russian. The general language understanding evaluation benchmark is actually a framework which consists of various tasks and requires the modeling of human intellectual skills on the text. So what we actually do is we model human intellectual abilities with the text tasks, including some abilities on logic, on making conclusions on the longer texts, also on having some common sense and expressing the knowledge, etc. So the benchmark itself collects the resources for training, evaluating, and analyzing the results of natural language understanding systems. For example, like BERT models, like transformers and autoregressive models and universal language models, etc. So I will start with the point that Alexei has already stated while presenting the talk, that the texts themselves, as an unlimited but the indirect trace of human thinking processes, are the richest source for AI that we have now. So what does this stand for? We do have like neuroscience, we have evolutionary psychology and like modularity theory, working together with MRI and fMRI studies, but still the high-level thinking processes have much more to discover, and we don't know much about how it's working as the high levels of the brain. But what we can do is we can base upon the text resources which are highly available, and there are a lot of indirect traces of the human thinking processes and other intellectual abilities which can be found in the text. So the things we can find in the text are like common objects and abstractions that we have, actions with those objects, and also the relations between them, the relations between the events, like temporal relations, entailment, and contradiction. There are some traces of empathy mechanisms found in the text, like common sense, and of course pure knowledge expressed, like in the academic books, etc. But as working with the text and being a linguist, I can say that the texts are this kind of resource which should be taken with caution. The texts themselves provide a rich source of biased information, and this bias is highly presumable by modern transformer models, etc. By the point of view of linguistic theory, the languages vary greatly by the difference, by the things that cannot be actually expressed by these languages. So if we are presuming that cognition and intellectual skills are universal, their expression in the languages is not at all universal. Like we have languages like Piraha in Amazonia, where we have no linguistic means at all to express like entailment relations between the events. We can say just two simple sentences and our listeners will comprehend that there is an entailment relation, but we have no ways to express it within the language. If that's a kind of an exotic example, we can move on to a more common one, like a Finnish language. Like in Finnish, there is no future tense. Do Finnish people have plans for the future? Of course they do, but the future tense cannot be expressed. And these differences lying on the basis is what the models actually learn, preventing them to transfer knowledge and to transfer the universal processes between the languages. So that's kind of a tricky question. And of course, the modern GLUE methodology is kind of Anglo-centric in this kind of way. And the other languages like Russian suffer. That's why we present the Russian benchmark today. There are also some other local projects, like for French language, there is FLUE, and for Chinese, there is CLUE, of course. So if we are working in the framework of one language and we are modeling the skills only in the boundaries of one language and testing on this particular language, the results are quite impressive. Like this is the actual leaderboard of the original English SuperGLUE. As you can see, the human level is about 89% of correct answers overall, over all of the tasks. And the best model, the T5 by Google, is like 0.5% worse. So that's kind of an impressive result. Ironically, the slogan of the T5 model is "text is enough." So, developing the Russian SuperGLUE benchmark, we have created from scratch all of the tasks of corresponding to the original GLUE benchmark, including textual entailment and natural language inference tasks, tasks requiring common sense and word knowledge, also tasks for logical abilities, and machine reading requiring some conclusions on longer texts, and also the diagnostic set on which I will touch upon later. So creating all the tasks from scratch in our approach is applicable to any language which is presented online or has some corpus of news or fiction, because some of these sources were like directly translated from the English original and then adapted for local realities, like for common sense. And also the other sources, the other tasks were collected by corpus filtration, so they are semi-automatic, and then they were manually corrected and annotated. So the most interesting part of the GLUE benchmark, I suppose, is the diagnostics. The diagnostics itself is that kind of a task which is used only for evaluating the models, not training, but only testing them. It stands for the universal ability of recognizing textual entailment between the pair of the sentences. And these sentences differ in one particular linguistic feature, which is being annotated on the pair. There is rich linguistic annotation in the diagnostics, requiring 33 linguistic categories on the 4 levels of the language, like semantics, logic, syntax, and knowledge. So while we were creating the Russian diagnostics, that was like a tricky question, both for us and for models to pass. For you to better understand how it's working, there is a kind of intellectual example of finding entailment between the actions in the text. So this is some piece of the news article, I suppose, we have crawled from the web. as an example of a good common sense task. So there is a house of youthful technical creativity somehow, and there are pupils who designs the fairy tale sled. And they are based on some tank sled that they have made earlier, and cut off the turret from the tank and built a new corpus of the sled and painted with hochlama ornament, since we are facing the year of the rooster. And the question is there an entailment label between the actions in this text? The answer is actually yes, because you should know that based on the common sense, the hochlama ornament is often painted with red and yellow, and it depicts animals and flowers, and that corresponds very good with the year of the rooster, which is actually the piece with entailment relation in this text. I suppose that's kind of a complex task even for humans, but also for models to learn, of course. So as the baseline for our benchmark for Russian, of course, we have used the naive baseline with TF-IDF model plus logistic regression, making the labeling task. But also, for the first time, we have tested the existing BERT models for Russian, the multilingual BERT and Russian BERT on Wikipedia. Also, the human evaluation was provided. And you can see now the current leaderboard for Russian. You can see that the human level of the annotation is 80% of correct answers, and there is still a lot to do for the BERT models, actually. So the quality differs drastically from the English analog. But why, and what should we do to make it better? So we move to the most interesting part of my talk, I suppose. As we have now two analogous diagnostics for English and for Russian with all the rich annotation of the categories, we can compare the transfer powers of the BERT model, the multilingual one, by training on the natural language inference task and test, are the categories, the problematic categories, the same? So as we can see, on the entailment task, the results are quite comparable, Russian being a little bit lower, but still the problematic categories are not at all the same, which is surprisingly, because the languages are not so different from the point of view of the linguistic family, not so far enough like English or Chinese. So a more comprehensive analysis of linguistic features should be used. And I would like to make a note that these features, which are included and also those that are not included in the diagnostics by now, are very much, which are actually well known, and are open databases containing all the distribution of their variety between the languages, like even with those with the maps like this. This is the project Walsin 4. So that's an open information which should be used. And now there are like other projects like Extreme and XGLUE, which are like multilingual glue benchmarks developing. Still, they are not using this kind of information, unfortunately, using some low-level tasks like part-of-speech tagging for transfer learning. So what we did with this multilingual diagnostics is we performed the linguistically aware adversarial attacks on multilingual BERT. So we have these 33 linguistic categories, which are, we believe, not universal, but well suited for English. And we have the diagnostics, which are testing the natural language inference task on the pairs of the sentences. What we did is we created a set of meaningless linguistic phrases containing one particular feature for each of the category, and we added these features to the pairs of the sentences so that the label won't change and the meaning won't change. And we checked the multilingual BERT stability in that kind of attack. So what we can see that, unfortunately, there are a lot of categories that are not stable at all, and while adding some of meaningless like prepositional phrase to the sentence, change the answer of the model dramatically, like 40% of the answers. So these categories, which are not stable, are both not stable for English and for Russian, and include the 4 levels of the language, actually, both logic and lexical semantics, and syntax and knowledge. So there is still a lot to do, and from the point of view of linguistics, by now, the multilingual models are not very much suitable for transfer learning, actually. But also, we have created the first general language understanding evaluation benchmark for Russian, and we will continue to develop our project in the field of multilingual diagnostics. As a last point, I would like to say that, of course, texts are a great source for transfer learning, but still there is a lot to do, a lot to develop in the field of methodology for text to be a better source for AI. Thank you.